Okay, sixth grade. Our objective today is to go over our homework from Tuesday, since we had a snow day yesterday, and we are going to move on to talk about polyhedrons today. What are they? What is surface area? And we should be able to get into surface area a little bit today. The big part of today, though, is just introducing the second part of the chapter. Quiz grades were really good, so again, if you didn't check your updated grade, the progress book is completely up to date. Sean? Oh, good. It's good to hear. Cool. So today might be kind of easy for some of you then. Good. Okay, so let me start with, I'm just going to go one page at a time. You guys already checked your homework for the warm-up today. So any questions on 1 through 13? Annalise? Okay. Yeah, that's not right because -7, like letter G, you have -7 at the end. -7 is much smaller than 1/9. No, 3 to the -2nd is the same thing as +1/9. And then 2 to the -3rd, you just move the 2 to the -3rd to the bottom, is the same thing as 1/8. So that -7 should be first. That's why it's letter I. -7 is much smaller than 1/9. 1/9 is smaller than 1/8. 1/8 is smaller than 1. Yep. The answer I have up there, yeah. You okay, Annalise? Okay, Emma? Okay, so 9B, Emma, all you had to do was subtract 0.00091 minus 0.0006. Did you subtract those two? I'm guessing maybe you converted it from scientific notation to standard form incorrectly. Remember, if it's a negative, you're moving it to the left, decimal point to the left. So for example, that 9.1 times 10 to the -4th, move your decimal point to the left 4 places. And then the 6 times 10 to the -4th, move the decimal point to the left 4 places. Okay, you should have 3 zeros in each of them. Okay, and then when you subtract each of them, you get 0.00031. You okay? Okay. Annalise? It is 6. Thank you, Annalise. Sorry. I don't know what. I was writing these early in the morning. Yes, it is just 6. Thank you for correcting me. Hello? Yes, I'm teaching, but go ahead. You sure? Okay, I'm done with them at about 8:30. If you could call me then. Okay. Okay, so I'll talk to Joe. Okay, so you're getting more than just no block. Okay. Okay, that parents are. Okay, I will talk with Joe and then I will get back to you. Thanks. Bye. Sorry, guys. Okay. Annalise, thanks for finding my mistake. It happens. Anyone else on 1 to 13? Doug? Or you asked me how to do it? Okay. So number 8, I know a lot of you guys asked me about this on Tuesday. I feel like today's Monday. On Tuesday, you asked me about it. Basically, I feel like you guys were trying to make it more complicated than it really was. All you had to do is figure out how many ways you can arrange pictures on a poster board with the restrictions they gave you. One way is you could have 3 rows of 20. 20, 20, 20. Okay? Another way is you could have 4 rows of 15. 15, 15, 15, 15. That's it. There's 2 ways to do it. Okay, Alyssa? No, it said it can fit up to 4 rows. That's okay. Yeah, that. Yeah. Yeah, I don't know. Your brains, I think all of you guys, your brains are programmed to think, oh, it's going to be probably more difficult. But that was a really easy problem. I think that was the problem, which is a good problem to have. All right, next page was 14 to 26. Alyssa, we'll start with you. Okay, 18, what part? Okay, so let me, if you don't mind, let me go over to the board so we can kind of reference both. So 18A, Alyssa, you should have used an equation, okay? So the total was $1,275.25 equals, we have to pay the broker a fee of $12.75 plus, what was the amount? Each share is worth $25.75. So basically, that's your equation you need. Yep. So when you solve for A, Alyssa, you get 49 shares. You okay with A? And then B says that you save $800 to buy more stock. So it's now the total is $800. You still have a fee of $12.75, but then the shares are now worth $31.49. So similar equation, but they're giving you different requirements or different information, I should say. So in this one, you get 25 shares. You okay with that? And then C is actually really easy. All you have to do is add up how many shares are here. So there's a total of 74 shares. If you multiply that by $28.36, you get the answer I have up on the board, which is $2,098.64. Okay. But you're okay now? Mary, about this one? Okay, that's not always going to be the case. That's interesting. You still need to throw that fee in there because you still have to pay your broker a fee for investing your money for you. But that just ended up working, so. See? Okay. You need to add up how many shares there are. Okay. Well, this is the new amount that they're worth. They just want to know if this is how much each share is worth, how much money do you now have? Does that make sense? Annalise? Okay, just start with your first one. Okay, well, let's just do 2 for now so I can get to everyone. Okay. 16, you're just solving the inequality. Yeah, you shouldn't get D. You just probably forgot about your negative sign. Yeah, the only thing you forgot about was your negative sign. Did you know, do you have your book in front of you? Before I do all this, did you know that there was a negative in front of that 3/4? You did? Okay. So negative 3/4 x minus 1/4 less than or equal to 3. Okay, Annalise, before you moved 1/4 to the other side, what did you change 3 to be? Okay, so then you added 1/4 to both sides, right? Okay, so you get negative 3/4 x less than or equal to 13/4. You still had that negative there? Okay, you just forgot about it, but we'll keep going. So the next thing is multiply both sides by 4. Did you do that? Okay, so 4 over negative 3. These cancel. Okay, you multiplied by a negative, so this should flip. Well, that still shouldn't matter because the answer doesn't have that in there. So that shouldn't matter. These 4's cancel. So you have 13 over negative 3. Okay. Did you have 13 over negative 3? And then all you're doing is converting that to a mixed number, which is negative 4 2/3. You told me you had D as your answer. D is 4 2/3. All you did was forget your negative sign. Ooh. Oops. Yes. Did I? Hold on. Oops, oops, oops. It would be helpful if I converted it right? Sorry, Annalise. I thought it was saying, I thought it was saying which one is a solution. I shouldn't be jumping ahead here. Okay, no. Okay, so the answer is A. Let me just explain this. The answer is A. Which one is not a solution? Because, and you not flipping the sign was probably your problem, because it tells you that all x values have to be greater than or equal to -4 1/3. So anything smaller than that, which letter A is smaller than that, not a solution. So my fault. I should read the directions again. So yes, one thing, Annalise, is flipping your sign. That made a huge difference. You okay with that? Sorry. And yet, what's your next one? Just give me one more for now. 17. Okay, so 17, let me just talk through the first part. If you donate 10 cents for every 1/4 mile, okay, there's 4 1/4 miles in a mile. Do you understand that? Okay, so if you take 4 times 0.10, that means that you're going to donate 40 cents per mile. Okay. Okay. By 0.10. That's what you did wrong. 60 times 0.10, and what'd you get? No, $6. You multiplied wrong. You can do it that way. There's a couple ways to do this one. Mary, you okay? You look tired. All right. Annalise, you okay with that? Okay, let me answer everyone else's questions, and they might end up getting to yours. If not, I'll come back to you. Emma? 24. Okay. 24, you should have, okay, they gave you 7.75 inches for every 38.75 feet. So this is your scale and your model. All you're doing is simplifying it, Emma. Okay, you can still do that. Either way, you're simplifying. So if you type that into your calculator, what did you get? Yeah. So 1 inch is over 5 feet, but you left yours as 5 feet over 1 inch. Just look for the answer, and it has to be G. You don't have your book in front of you. You're fine if you flipped it, but this is the only option that it can be. No, it's 5 feet, not inches.
Oh, okay.
Big difference. Like, do you see how we have the units up here? You have to have those units right, because 5 feet versus 5 inches is a big difference. Okay? Now, the order that you set it up doesn't matter, but look what the answer choice is. Okay? Mary? 19? Okay. This one's a little tricky. Okay, on 19, so Mary, the first thing is there's 40 meters in 1 second. The first thing you want to do is convert that to kilometers. Still keep it over seconds. Did you convert 40 meters to kilometers first? Okay, that's the first thing you want to do. Did anyone convert that to kilometers first and want to tell me how you did it? Okay, Annalise, go ahead. Okay. Give it to me as a decimal. You're going too far ahead of me. The first thing that I'm asking is, if you leave this in seconds, I just want you to convert 40 meters to kilometers. You're 3 steps ahead of us. Donatus? Thank you. Donatus, how did you do that? Good. There's 1,000 meters in a kilometer. So the first thing you need to do to keep it simple for yourself is put it into kilometers. Now they're asking you basically to change it to hours instead of seconds. So what do you need to multiply the top and the bottom by to convert it? Mary? Nope. You're changing seconds to hours. Not to minutes, to hours. Alyssa? Nope. Briar? Good, 3,600. Think about it. There's 60 seconds in a minute. There's 60 minutes in an hour. So you have to multiply each of those by 3,600 to get to hours. So that's how you get 144 kilometers over 1 hour. Adam? No. Meters. Okay, anyone else on that? Okay, so here's why. So 22, let me just read it. Which one is not true? So if you have similar triangles, Matt, all the angles are the same and the sides are in proportion. That does not mean the sides are congruent. No. When they're similar, yeah, no. Remember, that little squiggle means similar. Annalise? 22, it tells you the triangles are similar. So that means you know all the angles are the same and the sides are proportional. So it can't be G because if triangles are similar, that does not mean the sides are congruent. Yep, all the angles are the same. F is definitely true. Okay. That means they're proportional. H and I are right. G is the answer because that's the one that's not right. Okay, all you need to do is set up a proportion. So you should have 5 over 8 equals 6 over x, and you get 9.6. Okay. Okay, yeah, no, you want to do a proportion. Okay, anyone else on that section of answers? All right, let me get to the last section, and then we got to get moving here. Okay, 27 to 31. Mary? Okay, what part of it? Okay, so, if you look at B asks you, excuse me, probability that the sum of the two numbers that you chose is even. So all you have to do is circle the ones that have a sum that's even. So there's 4. So that means 4 out of 9 have a sum that's even. And another comment I want to make is you could use the multiplication counting principle here to determine how many outcomes there are. So you could have just multiplied 3 times 3 for the first hat and second hat. So you know that there's 9 possibilities. Now, C, maybe you're okay with C now, but basically in C, if you add a number 3 to the first hat, there's now 4 options in the first hat. There's still 3 options in the second hat. 4 times 3 is 12. Okay, so there's a total of 12 now for C. And they ask you, about the sum still being even. So it would be 6 over 12 now if you add a number 3 to the first half. 6 over 12 is 1/2. So it's going to increase it, Mary, because 1/2 is greater than 4/9. You sure? Okay. Adam? Yeah. Okay. Yeah, there's other ways to figure it out. I like to list them with problems like this because I don't know, tree diagrams I just think are kind of a pain. You can still draw it if you want, but again, you had to look at all the outcomes here. Okay, Matt. Yes. Yes, I'm trying to get to them. Doug. Okay, give me one. I just went over 27. Okay, did you listen to me? That's fine. Whatever you got, that's fine, but it's not right. Did you listen to what I went over with Mary? What part of what I explained do you not understand? Okay, you may explain it again? Were you listening? Doug, were you listening? Okay. In C, they're adding on a number 3 to the first hat. So if they're adding on a number 3 to the first hat, there's now 4 options for the first hat. Do you have your book? Okay, that's probably part of the problem. 3 options for the second hat. So there's now a total of 12 different outcomes that could happen. If you count up how many of the options are going to be even, there's 6 options that are going to be even out of the 12. So all you're doing is comparing, if you add a 3 to what we originally had. So it's an increase because half is greater than 4/9. Okay, make sure you listen so I don't have to explain it twice. Annalise? Okay. You can either do guess and check and just keep going, or you can set up an equation. Okay, Annalise, and the equation would be you start with $500. So you could have for your side 500 plus your amount goes up in increments of 15x. And then your friend had started with $400 and hers went up in increments of 20. So you could have set up an equation like this. If you solve for x this way, you get 20 years. Say that again. Yeah, but did you hear what I said, though? Each year. Not 5 years. Each year, yours is going up $15. So it'd be from 5 to 6. Okay, each year. So this is one option, is set up an equation, see what's happening each year. Annalise, the chart is tricking you. If not, do guess and check and figure out when they're going to be equal, which is at year 20. Honestly, I think the equation is much easier. It would just take a long time. You just plug them into the equation. Is that what you did, Adam? Okay, well, that's smart. Okay, Mary? You mean like you got year 3 wrong? Okay, so for year, go over here. For year 3, you should be putting 500 times, in parentheses, 1 plus, oh, the friends one. You got all these right? Oh, that's weird. Okay, so for the friends, you should have, let me look at what they gave us. 400 times, in parentheses, 1 plus 0.05 times 3. You get 4. No, it's not compound. Simple annual interest. You thought it was compounded. It's simple annual interest. It tells you in the problem that it's simple annual interest. You probably just read the problem wrong. It's not compounded interest. You sure? Okay. All right. We're going to move on, okay? If you guys have any other questions, let me know tomorrow or at the end of class. Okay, I need you to open up your notes to 10.5a. 10.5a. going to shut these off so we can see a little better. We are talking about three-dimensional figures in this lesson. Kind of fun. Donatus? Say that again? Well, eventually. We need to talk about all of them first. So, is this a prism or a pyramid? Doug? No, that's not the question. Is it a prism or a pyramid? Good, prism. Is this a prism or a pyramid? Mary? Good. Is this a prism or a pyramid? Matt? Good, prism. Is this one, Annalise, a prism or a pyramid? Good. It's not. There's just hard to see. There's a sphere in here. It's just hard to see, probably. It's in there. All right. Did everyone find 10.5a, Jeremy? No, it should be open up to 10.5a, which is page 11 in your notes. Okay, so we're going to do kind of an overview of what a polyhedron is, what a pyramid, what a prism is, before we talk about surface area, okay? So the fancy word polyhedron, a solid figure that is bounded by polygons that enclose a single region of space. Mary? Yep, here's one. Here's one. Yep, still is called a polyhedron. 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 We're going to get to that, so hold that thought. No, there's not stuff in there. No. Mary? Correct. They're not polygons. They're still going to be a branch of a polyhedron. Wait till I get to it. They are not polygons, so you're exactly right. Donatus? What did you say? Oh, I'm sorry. I'll let you do the next one. Sorry, Donatus. Thanks for being on the ball today. Okay, so a face. It's kind of funny because now these shapes are going to have something called a face. So it's like they're looking at us, huh? The polygons that form the sides of a solid. Now, you don't have to write down this in parentheses, but you can if you want. Faces of the polyhedrons are polygons. So this is where we get into cylinders and spheres are kind of outside of this. We will talk about those ones separately. So if you look at this prism that I have, what is the face? What is that? Briar? Good, it's a pentagon. What about this one on the bottom? Briar? Good, pentagon. So of course they're bases. These are the bases. They're going to be the same. A base is also a face. So you have a bunch of things here. What would this face be? Mary? Good, a rectangle. Okay. Donatus, would you like to talk about the base? Yep. And this is how we figure out the formula is by the base. So a polygon that is used to name the polyhedron. So does anyone know what the name of this would be? Charles? No. M-A-H? Pentagonal prism, because pentagonal prism, here's the two bases, which you could also call a face, okay? What about this one? If you guys can see, okay, what is the name of this one? Doug? Good, triangular prism. What about this one? Alyssa? Good, it's a cube. And what else could you call it? Good, Adam. Okay, or just a square prism, but a cube is the technical word of it. That one's not a rectangle now. Okay, the next term is an edge. You didn't? What are you doing over there, sleeping? Mary, go ahead. You can call it that. Yeah. Go ahead, Adam. Go ahead. Snake. That's a little far beyond, so maybe not. Okay. Guys, come on, because we don't only have 8 minutes. Okay, Adam. Save it for later. Okay, edge. The segments where the faces of a prism or pyramid meet. So, Emma, turn around. So here's an edge, here's an edge, here's an edge, here's an edge. Okay, all these edges. It's kind of, in my mind, I think it's common sense. Think of a box where the edges of the box are. Same thing as these are edges of a polyhedron. Okay, it's where they meet. Now, if I have a pyramid, it works the same way here. This is our pyramid. There's still our edges here. The biggest difference between a pyramid and a prism is what? What's the biggest difference between a pyramid and a prism? Sean? No. I mean, well, actually, yeah, maybe I shouldn't say that. The word always kind of throws me off sometimes. You could be right, but I just don't like the word always because there's always an exception to that. Anyways, okay, it's true for the ones I have over here. But what's the biggest difference besides that, possibly? Between a prism and a pyramid. Big difference. Sean, go ahead. Okay, but that's not what I'm looking for though, Briar. Good. Just in general, a prism has 2 bases, a pyramid has 1. That's another big difference. Okay, vertex, the points where the edges meet. Let's get some more of these out. So vertex is anything where the points are. It's just the vertices where the edges meet. So here, 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 etc. Okay. Justin, you have a question? We're going to get to those. Just hold off on cones for now. Here's one. Kind of. But it's called a cone, not a pyramid. Okay. Emma H. Yeah, that actually is a good idea. I would like the weather to be nicer for us to do that, and then we can analyze the dimensions of a cone. Find the surface area and the volume. Annalise? Go ahead. Correct. It's kind of like a branch of them. We're going to get into the more specifics of cone and cylinder, just not yet. Yes, and I have some shapes where we can unwrap them. We're going to talk more about that tomorrow. But the round surface of it makes it not, it doesn't fit all the characteristics. Hold on. Wait, I'm going to show you tomorrow. Okay, we're going to talk about that tomorrow. So just hold your thought on those. Okay, so vertex. Everyone write down vertex. Go ahead, Matt. Oh, geez, Matt. Yes, that's not important, though. Yes. Okay. All right, net. Okay. A 2-dimensional representation of a solid. So I'm going to show you this tomorrow. Mr. Warnock has my other box of shapes. This is where we could have a polyhedron. Okay, and I'm going to show you how to unfold it so we can talk about what it looks like. Bless you. Right, you can just write down what's in blue there. That's enough. So a 2-dimensional representation of a solid. And again, I'm going to show you tomorrow how these unfold. I want to have a discussion about these. These ones don't. These ones just open. I just don't know if my nails will open it today. He's just curious today. All right, prism. Okay, a solid formed by polygons. And then they have 2 congruent bases that lie in parallel planes. The other faces are rectangles. So there you go, Sean. to be more specific. Instead of quadrilaterals, rectangles. So again, a prism, it's a solid formed by polygons. It always has two congruent bases that are parallel. Like common sense, they have to be parallel. Okay, the other faces are going to be rectangles. And I wouldn't say always. Charles. Correct, yeah. Yeah, that'd be cool if this was science. We could do an experiment, huh? Annalise. Correct. Yeah, I should put on, the book should put, this is from the book, they should put on there that the other faces are sometimes rectangles. Yeah, because it's not going to be every single time. Again, your book sometimes, I don't know, they like to stretch things. Okay, a pyramid, a solid formed by polygons. The bases can be any polygon, and the other faces are triangles. Go ahead, Charles. Say that again, if it has a what? If a pyramid? Yeah, but your book calls it a triangle pyramid. But that works. Emma, is this a question? Go ahead. Real quick. Okay, hold that thought. But is it a question? No, then hold that thought. Okay, I need to explain homework. The last two definitions I'll give you tomorrow, okay? So open up your homework packet. This is just an introduction. This homework's not going to be hard. Open up to page 151. It's not hard, trust me. No, just regular 151. And also 151B. Let me just explain what you're doing. Okay, so tell me that 151 is pretty easy. You're just naming them, okay? 151B, okay, I just want to make sure you guys are clear. It talks about faces, vertices, and edges. So real quick, don't forget, face, 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 vertex, I should say. These are the vertices, and these are the edges. So homework is just an introduction to what we did today. It's not hard. Sean? Hexagonal pyramid. All right, so that's homework. If you have questions, come see me. Go ahead and get packed up. Annalise, you can come up and ask. Okay, I'll see you guys tomorrow.